Hello class, we are looking at lesson 8.3, which is multiplying powers and then working with scientific notation. As with all of the previous lessons, please make sure you're watching the video, taking notes, practicing, and asking questions in class, and working on the class discussion as well. So our rule for multiplying powers with the same base, and this is extremely important, they can only be with the same base. So the rules are for every non-zero number a and the integers m and n, a to the m times a to the n gives you a to the m plus n. Okay? So we can see here how if we have the same base of 3 to the 5th times 3 to the 4th, we can take and make that one base of 3 and add our exponents of 5 and 4 to get 3 to the 9th. Notice this is only working with multiplication, and we're multiplying the same base. It doesn't work if we don't have the same base or if we're not multiplying. Okay? So let's apply our rules. We have 7 to the 3rd times 7 to the 2nd. If you think about this, 7 to the 3rd is 7 times 7 times 7, and 7 squared is 7 times 7. Okay, we're multiplying. Remember, our multiplication properties of equality our multiplication properties tell us that we can multiply in any order. So it doesn't matter which 7 we multiply first, we just keep going down the line. So in actuality, 7 to the 3rd times 7 squared becomes 7 to the 5th. Now, this is a little trickier, especially if we don't like the negative. We can do this problem one of two ways. I'm going to show you the way that our rule tells us here in Investigation 3, and then we can look at it from a different perspective in Lessons 4 and 5. So in this case, our rule tells us we just take our base and we add 8 plus negative 8. For those of you that are weak in your integers, you have to be very careful. 8 plus negative 8 is the same as saying 8 minus 8, which gives us 6 to the 0. And what is 6 to the 0? That is just 1. Go ahead and try a quick check 1, parts A, B, and C, and then we will move on to the next example. All right, so in looking at our quick check results here, 5 to the 3rd times 5 to the 6th becomes 5 to the 9th. And if you want to think about it in expanded form, again, the rule is when in doubt, write it out. If you write it out, think about what is happening. You're just multiplying a bunch of 5s. Well, how many 5s do you have? 5 to the 9th. In example B, we've got a positive and a negative. And if you follow the rule, you get 4 minus 3, which is 1, 2 to the 1st power. However, think about what 2 to the negative 3rd is and 2 to the 4th. That's 2 times 2 times 2 times 2. But in the denominator, we have 3 2's. So 2 divided by 2, that you start canceling those out, your result is just 1 2 left in your numerator. If we look at example C here, we've got 3 7s being multiplied together with various powers. So again, if you follow the rule negative 3 plus 2 plus 6, we get 7 to the 5th. However, if you think about it, again, when in doubt, write it out. When you start to write it out, and then you start to cancel out as many 7s that you have in the numerator and the denominator, you reduce that, and you're left with 7 to the 5th. Again, if you need to pause this and check your quick check again, go ahead and do so. We're moving on to multiplying algebraic expressions here. Okay? My rule is I like to rearrange the pieces of my puzzle so that I have my numbers and all of my letters next to one another that they're like, okay, those like terms. Remember, our rules for adding the exponents only work with the same base. So in this case, I rewrite 4 times x to the 6th as 4 times x to the 6th. This 5 times x to the negative 4 becomes 5 times x to the negative 4. Spread it out, expand it out a little bit here. So I'm going to rewrite this as 4 times 5 times x to the 6th times x to the negative 4. 4 times 5 gives us 20. X to the 6th times x to the negative 4th, if we're following our rule, gives us x squared. Okay? So the same thing with example B. I'm going to do this a little quicker now. I'm going to rearrange my 2 times 3 times 4. And then I have q, and that's q to the first. It's understood to be there. I'm going to write that 1 just to remind us. And then I'm going to put my q to the 4th there. And then I have p to the 3rd. Okay? So again, 2 times 3 times 4, that gives us 24. Q to the 1st times q to the 4th gives us q to the 5th. And then p to the 3rd is p to the 3rd. Okay? Go ahead and try the quick checks. And again, when you're done, restart the video and check your answers. All right, so we're looking at quick check 2, examples A, B, and C. The answer to 2A is 7n to the 6th. B is 28x squared y to the 7th. Go ahead and check your work. Make sure you're careful and you're not losing anything along the way. C had a combination of both, and so you want to make sure that you are checking your signs. All right, we are now multiplying scientific notation numbers. And the beauty of scientific notation is that we don't have to worry about all of those decimal places and counting and all of that. It's all done for us. So that is a great help. So when we're multiplying numbers in scientific notation, remember we can multiply in any order. So if you think about what we've got here in scientific notation, we have 3 times 10 to the negative 3rd times 7 times 10 to the negative 5th. So just like we did in our multiplying powers with algebraic expressions, we can do the same here. I'm going to rearrange it so I have my numbers multiplied together and my powers of 10. Okay? And then 3 times 7 is what? Well, that's 21. We can all do that in our head. We don't have to grab a calculator for numbers like this. And then 10 to the negative 3rd times 10 to the negative 5th becomes 10 to the negative 8. And powers of 10 are really the only time where we will leave the negative power. Anything else, we would move it to the denominator. But in this case, scientific notation, powers of 10, we leave it. So we have 21 times 10 to the negative 8. Now, 21 is not in proper scientific notation. So we have to write that as 2.1 times 10 to the first times 10 to the negative 8. Well, again, we can combine those to make 10 to the negative 7. So hopefully these are starting to make a little bit more sense, and you can see why and how we're working with scientific notation numbers. But notice I didn't need to grab a calculator at all. Okay? Go ahead and try the quick check, and when you're ready, you can check your work. Okay, so here we go. In example 3A, we have 1.5 times 10 to the 12th. Check your work. Here's my work here. Okay, in example B, we end up with 4.5 times 10 squared. And then in example C, we have 6.3 times 10 to the negative 14th. Okay, if you've got any questions on those, please make sure you email me. All right, here's probably the most difficult part, and this is our factor label method using dimensional analysis. This is where students start to get a little bit confused because this is the application part of scientific notation and exponents. So we are looking for the speed of light. Okay, the speed of light is 3 times 10 to the 8 meters per second. All right, so we want to find the speed of light in kilometers per hour. All right, so I want you to think about what we're starting with. 3 times 10 to the 8th. Think about your units, meters per second, okay? And then we have, we want this to be kilometers and we want this to be hours. Well, how many seconds are in an hour? And we're given that conversion right here. There are 3.6 times 10 to the third seconds per hour. Okay? And then let's get our meters to kilometers using this one. 1 times 10 to the negative third kilometers per meter. Think about your units. Meters per meters cancel out, seconds and seconds. So the only units that are left are kilometers per hour. This is what we call factor label. Again, because we can label our units and see what's left. And that tells us what our answer is, or what we want our answer to be in. So now we look at the numbers and we're multiplying 3 times 10 to the 8th times 3.6 times 10 to the third times 1 times 10 to the negative third. Okay? So if we take 3 times 3.6, we get 10.8. And then 10 to the 8th times 10 to the third, that gives us 10 to the 11th times 10 to the negative third. We subtract 11, so we're left with 10 to the 8th again. Okay? Now we need to write this in proper scientific notation. 10.8 becomes 1.08 times 10 to the first times 10 to the 8th. And then we combine our like terms, our powers of 10, and we get 10 to the 9th kilometers per hour. Okay? Meters per second, kilometers per hour. Go ahead and try the next quick check and check your work when you're done. Notice what I did here is I set up my problem. This is what I'm starting with. Microliters per pound. Okay? And then they give me enough information here. I know there's 5 times 10 to the 6th red blood cells in 1 microliter, and that the person weighs 160 pounds. So my microliters will cancel out, and my pounds will cancel out. And the question asked how many RBCs, right? Well, that's the only unit that's left. So this tells me I set the problem up right, I can do the math accurately, and then multiply my numbers together. There's no guessing whether you multiply or divide. The units and the problem set it up for you. After we compute all of our values here, we're left with 2.56 times 10 to the 13th. RBCs. Okay? Again, this is probably the example you're going to want to focus on, the application. We'll do some examples in class. If you have any questions, please send me an email or write them in your post-video check. Thank you.